Hello all, welcome to my channel. I'm back with a video on Flink. So in this video we will be discussing how Flink offers window processing. To start with, windowing is a technique that divides a stream of data into finite chunks. So when I say finite chunks, it's a division in such a way that certain elements will be present in one window, certain elements will be present in some other window. This division is based on certain criteria. And that criteria decides in which window an event will go. It will also decide when it gets processed. It will also decide when it gets evicted out of that window. So Flink has a very robust windowing mechanism. It uh, it has what you call a window system which has majorly two components. So Flink window can be broadly divided into two components. One is the window assigner, another one is the window operator. So this assigner's job is to assign new events to the window, and operator processes that particular event, maintains the state, applies the trigger, executes the functions, and then returns the response. So at the broad terms we have assigner and operator, but inside operator we have many components, and those components are window functions which are used to process the event. Then we have window trigger, we have window evictor, and watermark. So what does a window function do? Is simply it's the function which decides how that events are processed or aggregated or added, counted, summed. So that kind of the function is applied on that particular event. Then the window trigger decides when that window which is being processed or which is in question gets triggered or gets processed, like that window is complete, and then we say, okay, this window is complete and I'm going to execute my function on top of it. So that is decided by the trigger. Then we have evictor. So evictor is something which says when we will be removing the uh, event from that particular window once it is processed, or do we really want to keep that, or we want to remove that. We will see, depends on what window strategy that we are using. And then we have watermarks. Watermarks are a way for Flink to handle the old data, or sorry, late data. So let's say if we have a window and some records came after that window has ended, but that should belong to the window that has already processed. So how do we handle those scenarios? And for that we use a strategy called window I say watermark. Now, so we have as we saw, the first component is window assigner. So based on the window assigner, we will have different window concepts or window types. For example, we will have tumbling window, we will have sliding window, we can have session window, we can have global window. So in it's based decided based upon how the assigner assigns a particular event to a window. So let's in case of tumbling window, what happens is that window size is fixed. There is no overlap. So it means we will have records from 11 to 11.5. Then we will have a window from 11.5 to 11.10. Then we will have another window from 11.10 to 11.15. There is no overlap. So all the windows that are there all will be separate and they will not share any particular state with each other. But when it comes to uh, in the tumbling window, each event that will come will only be present or processed once, because it is part of a one single window. It is not part of multiple windows, so it will not be processed multiple times. Then we have sliding window, which is and something similar to tumbling window, but it slides the window instead of completely disappearing and appearing at a later time. It happens is that the window slides by the time that we have given for the windows to be moved. So for example, let's say if we have event uh, which arrives at 11, and the window size is 5 minutes, so 11 to 11.5 is one window. The next window will start, let's say if we have given a sliding range of 2 minutes, so next window will start from 11 to 11.7. Then next will start from 11.4 to 11.11. So in this, if you see the first window, which was 11 to 11.5, the records from 11.2 onwards till 5 will be part of the next window as well, because the next window starts from 11.2 to 11.7. Similarly, the events which are part of 11.4 to 11.5 will also appear in the next window, which is from 11.4 to 11.9 or 11. So based on the window's length that we have decided. So in this way, what will happen is each event might get processed multiple times. So, and the reason why we use these cases is, for example, let's say we want to calculate uh, rolling average or rolling or cumulative average of few things in the data stream that is coming. Let's say we want to see for a particular YouTube video how many likes were there in the last 5 minutes, and last 5 minutes keep on moving every 2 minutes, right? So first 5 minutes, let's say we have 20 likes, second time 5 minute window which is there. So in that case, we'll have to keep the sliding the window to find out the rolling average. So that's where this sliding window comes into picture. It is defined using a hop for example, the syntax wise tumbling window is defined by tumble and sliding window is defined by hop. Next comes session window. So this is again, it is similar to tumbling window, but the size is fixed. Sorry, size is not fixed. It is uh, dynamically sized. In a sense, it will the session will start and will keep on the session will or the window will keep on increasing till we have activity that links to the previous event. Previous event. For example, let's say we have logged into any website and we are doing something. Let's say we log into IRCTC and that window starts like, or let's say ITR filing. That time also a window starts that okay, you have an active session of 15 minutes. So what happens if we don't click anything? It will give a pop-up that you are idle and we will terminate your session. How that happens is, but if we keep on clicking, that 15-minute window keeps on extending. So that is what this session window means. So for example, if we have continuous stream of events tied to a particular session, the session will keep on increasing and the newer events will keep on adding to the same window. But let's say if are idle for 5 minutes, or let's say the defined window is at 10 minutes, if you are idle, then a new session will start. Or let's say so what will happen for the last whatever session you were doing that work will be processed in the previous window, and when you again click on and become active, the new session starts and your the events for that session will be processed in a different session. And these session windows are uh, used for cases where we want to maintain uh, aliveness or liveness of particular process. So this is used in there. Then let's say we have another window which is global window. This is very seldomly used in Flink processing. I have till now generally never used in any of the production workloads a global window. Global window is something which never closes, which means that it will be a single window and all the events will be part of that window. So for example, if you want to keep track of how many events are coming, you say select count star from your stream, and it will keep on emitting the counts as and when the numbers are coming. So for example, YouTube subscriber count, that can be something which is a global window, because we are not interested in how many subscribers you are gaining in the last 5 minutes, but basically we are trying to see how many total subscribers do you have, and if that we have a requirement of doing it in live. So that's where this global window comes into picture. Now, based on the we said that we have already seen the signer, and then we had the window operator, and that operator had as we saw, operator had multiple components. So based on that particular components, for example, trigger, we will see uh, what are the components or what are the things which are present in a window trigger. So window trigger has basically four components: element, event time, processing time, and then merge. So trigger is actually what defines that when an event will be processed, or uh, as it determines the window as formed by the Windows assigner, and whether that window is ready to be processed by the window function that we have created or not. So based on these semantics, it will decide when to start processing the window. And now we also have an evictor which was part of the operator pattern. So based on this evictor we will have different kinds of evictor. Evictor is something which removes the elements from a window after the trigger fires. Okay, and but it may happen before or after the window function is applied. For example, let's say we can say that uh, in a window we should have, let's say, x number of events. Let's say we decided that, okay, let's say we are calculating average and we said that, okay, in a window we should only have 10 records. So this count evictor will keep on adding elements till the counter has reached to that 10 number. The moment it reaches at 10, it will start it will the window function will be called. Sorry, the event, once the event processing has been triggered, it will check the how many events were processed in the last window, and then it will say that, okay, older records which are not part of this window based on the count that we have, I will discard those records. So in that way it will evict that. Similarly, we have delta and time. Time is based on how, based on certain time, that, okay, this is the older data that we were looking at. Let's say we have a 5-minute window, so we will see the event time, which is event time of the event that has arrived. Is it falling in that 5-minute window or not? If it is falling in the 5-minute window, we will be keeping it. Let's say after processing, if that 5-minute window is done, then we will remove that particular event from the window. So that's the job of the evictor. Then we also saw some are the time attributes which are present on Flink window. So there are three, basically: in time, road time, and proc time. So the proc time is the processing time which the machine system is using. For example, it can be an epoch. So when that events function or the events processing function was triggered, at that time, whatever is the timestamp, whatever is the timestamp, which is Unix timestamp epoch value on that system, it will assign as a processing time or proc time. But let's say if we want to process events based on the event time, so then at that time we will have to use road time. Road time is the time at which the event was created rather than the time at which event is getting processed. So these are different time attributes. So now comes the point that if we have time things coming into the streaming scenario, we might have scenarios where the data is coming late, arriving late. So for those scenarios, Flink offers a mechanism called windowing. So watermarking. A watermark is a threshold that indicates when the Flink expects all the data of a window to be present. So basically, let's say if we are saying the window is 11 to 11:05, so we are saying 11 to 11:05 events can arrive by 11:06. That's our toleration saying that, okay, we will tolerate 1 minute. So when we apply this watermark, what will happen? The events which arrive at, let's say, 11:05, let's say 5, and after, let's say, 5:30 seconds, means after the event has event windows boundary, it has arrived 30 seconds later. So, but because we have a toleration of 1 minute or 2 minutes, then that event will still be considered part of that window and it will be processed. And this watermarking requires the state to be maintained. So let's say how this happens is, let's say we have two dimensions. One is processing time, other one is event time. So in normal cases, the event times will be like the event will be generated and it will be processed as soon as it is arrives in the window. Like in a sense, it is arriving on the right time. But let's say it happens that some events are coming late. So in here, if you see, we have some events which are coming after the event time has already crossed and processing time is slightly delayed. And then let's say all the this orange line is the boundary or the watermark that we have defined for this particular window. Now if there is one event which came outside of this window, but the other events came which are perfectly fine in the coming in the window itself, then those events will be processed. This event which is coming outside of that watermark will not be processed by Flink windowing. It will say that, okay, this is something which is late, and it is late even beyond the toleration that was given to the window, and it will discard that particular record. And the reason why this is implemented is there are two things. One is that data is not guaranteed to be coming in the predictable time. Like it can come after some time, so that's where this watermark helps. Another one is events might not be coming in the order. let's say event order might change. For example, event which was generated at 11:04 came at 11:06, while the event generated at 11:05 came at 11:05 itself. So the order is also, if we have order requirements that we want the data to be processed or the window to be processed in a certain order, watermarking helps in there. So yeah, this was all about how Flink processes a window. Hope this video was informative, and if you like this video, do share and let me know in the comments what next concepts you want me to make a video on. Thank you. Bye bye.